right, let's go ahead and get started. My name is Wesley Hill,
And I'm Wong Swasri-san.
and we are representing the Running Robots project today, which we will be showcasing to you throughout this presentation. So the company we are working for is the School of Computing. We're not working under any in-industry company, it's just under the school. Specifically, our executive sponsor is Dr. Chris Bohn. We've been working under him through the duration from August till now, and he's been the person kind of directing the project's direction and telling us what he wants. Then moving on to the faculty and staff, we have our project manager, Bill Browning, and our tribe lead, Jeffrey Falkenberg. These are the people on the side of the school that have been helping guide us throughout the year, grade us, and just giving us general advice as we've progressed. Then moving on to the student leadership, I am the multi-team squad lead. Our team is a multi-team, so we are comprised of 10 people rather than 6 people.
And I'm the product manager for the team. And we do have a third member, Thad Post, who is the development manager.
Yep. And then moving on to student team 1, we have Matt, Tegan, Jake, and Aaron. They've been working closely throughout this past year. And then moving on to team 2, we have Indigo, Raul, and Dimitri. They have also been working together. And Thad is unofficially on team 2, but he is also the development manager.
So getting into the problem and opportunity, some of the problems with robotics can be a high cost of entry, it's not very replicatable, and oftentimes you won't find super modular or portable systems to go with it. So one of the opportunities that we had coming from this was the ability to create a product that would allow for a very replicatable, recreatable version of robotics that maybe students or institutions could create their own versions and maybe participate in intercollegiate games or inter-school competitions. So kind of the goal and the main focus for us was to make sure that it was cost effective, it was portable and recreatable. So onto our solution. We started with the brains of the robot, and for the brains we wanted a Raspberry Pi. We selected the Raspberry Pi 4B to go with and handle the motor control. This allowed us to also have a live camera feed, and also that led us into implementing a VR view using a Google Cardboard. That, along with adding infrared emitters and receivers, is how we have launched it into kind of a laser tag-esque game. And to complement this, there is a web application and a BFCM, which is our backend, that allows for the scoring to be registered and also for the gameplay to actually happen, and you'll have a visual feed of score tracking and what robots have joined or left the games. So for the product solution, with our robot here, it's using a metal base body with a tracked driving control. On the bottom undercarriage, there is a ultrasonic sensor. That's what we use to kind of get like a little distance indication from it, as well as the Raspberry Pi 4B. And on the top side, just to make sure that everything was replicatable and created by and recreatable by other students, the top side is 3D printed tank header and a mounting box that houses our servo. And in the barrel, you'll see a little IR emitter coming out and a IR receiver sticking out of the top of the tank header. And we had started development on a PCB that would allow us to create our own header unit for the Raspberry Pis, allowing us to create connections for exactly what we would need for the project. This is mostly kind of like an outline and template for future teams or other institutions to try recreating one as well.
All right, that was more the hardware-centric part of our product solution. Now on to more the software side, starting with our mobile application. This was specifically built for Android devices. We first start on the home page with this kind of retro aesthetic to it, specifically with the Running Robots logo and then the logos beside it. Once you press connect, you then get a list of robots that are available on your Wi-Fi. And once you connect to one of them, you get that second screen, which we call the control view. At the center of the control view, that is the live camera feed that Nathan was talking about. You're able to see basically from a first-person perspective of the tank with that camera that's mounted on top. To the left of that camera feed, or to the left and right, are the joysticks. Those are for skid steering. The left joystick controls the left tread, right joystick controls the right tread. Also, to the left of the camera view is the camera movement. You're able to move the camera left, right, up and down, although the chassis that we currently have does not support up and down movement. That was a previous iteration. And there's also a or a direction indicator in the center of that, indicating if you're looking right or left from your center view. Then on the right side, you can see the shoot button. That is to shoot the IR signal like Nathan was talking about. When another robot is hit by an IR signal, it disables it. It says disabled in big red text in the middle of the camera, and you can't move or shoot for about 5 seconds. And then lastly, in the top right is the VR view button. The VR view is intended to be used with a Google Cardboard headset. It specifically splits the view into two camera views, and it creates a fisheye lens effect so that when you put the Google Cardboard on, you're able to see it as like one image. And it's meant to be more immersive. It's so that you can't see the full field at once, so that you can only see what your tank sees, kind of restricting the amount of information that you have at a given time. That's it for our mobile app. Moving on to our web app, you see kind of the same aesthetic. We tried to keep them very consistent. You see, once you press Start Game, you have a pop-up. You can choose whether you want to play laser tag or capture the flag. If you press laser tag, you're moved to the laser tag scoreboard. On the left is the timer. That's how you start and end a game. You set how long you want the game to be. You press Start Game, it starts the game. When the timer runs out, it automatically ends the game. So the scoreboard on the right is automatically populated whenever a robot joins, or whenever a phone connects to a robot, it automatically joins the game. Whenever you shoot with a robot, it increments the shots fired. Whenever you get hit, it increments the hits landed for whichever robot shot you. And then lastly is the Capture the Flag scoreboard, the other game mode. It's a lot simpler. You just can increment and decrement the team's score depending on who scores the ball into the goal. And then moving on to our value and highlights.
So some of the core values that we have implemented into this is making sure that it's fully open source and reproducible up till now. For other institutions, that should enable them to be able to replicate and also adapt their own. The whole point is to be able to be creative with how it goes going forward, not just for the next team taking over for us potentially, but also for anyone else that wants to try recreating this at home. The other values was we wanted to make sure it was engaging for the users. We wanted to have different capabilities for the robots, VR, laser tag, capture the flag, ultrasonic sensor, etc. And eventually, with maybe some more work and some potential to it, could scale into some sort of inter-school or intercollegiate kind of robotics competition. For some of the highlights, looking back on from where we started to where we took it to the end, when we first inherited it, we saw it was a lot different. We used an Arduino-based control and RC controllers instead. Those didn't quite give us the capabilities to create what we have today. So changing that to Raspberry Pi fully operatable tanks was one of the focuses for us at the beginning. We also had a lot of custom 3D printed mounts that all had kind of different uses, and that allowed us to create something a little bit more custom. Integrating the VR and the live camera view capabilities kind of just added a layer of depth to what the project could do. And for another thing that we inherited was a web app. And then we created our own mobile app, allowing it to have a more complete feel. So now you can control the robots on the phone and also have a web app for the scoring, and you can kind of watch everything live as the counter is going up. And we also, on top of the laser tag game mode that was inherited, there was an addition of the Capture the Flag game mode that, if any of you guys saw it downstairs, was running for most of the day.
All right. Thank you, everyone, for attending our presentation.